This video is conceptualized and created by Professor Rajeev Kumar Bhattacharya of the Department of Civil Engineering, IIT Guwahati. It highlights the origins, key developments, and applications of linear programming in engineering, economics, and operations research. With engaging visuals and clear explanations, discover how linear programming has shaped modern decision-making and optimization processes. Don't miss this insightful overview. Monica had always been fascinated by the mathematical world, but lately, one concept in particular had piqued her interest: linear programming. She'd read about its vital role during World War II and was eager to understand how it developed and how it worked. So, she decided to meet her friend Krish, who had a knack for making complex ideas easier to grasp. As they settled in with their coffees, Monica began, "Krish, I've heard a lot about linear programming, and I really want to understand it. I know it's widely used in industries, but I don't know how it all started, or how it actually works." Krish smiled, sensing her curiosity. "You're in for an interesting journey, Monica. Linear programming, or LP, has a rich history with contributions from several brilliant minds. Let me break it down for you." Monica leaned in, intrigued. "Great! So, how did it all begin?" Krish explained. Linear programming took off during World War II. The military needed to figure out the best way to allocate limited resources, fuel, supplies, manpower, to maximize their effectiveness. One of the first pioneers was a Soviet mathematician named Leonid Kantorovich. In 1939, he developed an early version of LP while working on optimizing production in a plywood factory. Unfortunately, due to the geopolitical climate at the time, his work remained largely unnoticed for a while. Still, he laid the crucial foundation for what would eventually evolve into modern linear programming. Monica, her brow furrowed, interrupted. "So, what about Kantorovich? Did he ever get the recognition he deserved?" Krish smiled. "Yes, actually. It took a while, but in 1975, Kantorovich was awarded the Nobel Prize in Economics, along with Chaling Koopmans, for their work on resource allocation. Even though his contributions were largely overlooked during the war, his early insights were groundbreaking. He finally got the recognition he deserved." "That's really inspiring," Monica said, nodding. "And what about the simplex method? I've heard it mentioned before," Krish nodded. "Exactly. That's where George Dantzig comes in. In 1947, he developed the simplex method. An algorithm designed to solve linear programming problems. This method was revolutionary because it could handle large, complex systems of equations and inequalities, allowing people to find the best solution. It was especially useful for military operations, and later, industries adopted it too." Monica raised an eyebrow, sensing there was more to the story. "And after Dantzig, who else contributed to its development?" Krish continued. "A lot of key theoretical work followed. For example, Harold Kuhn and Albert Tucker made a major contribution with their Kuhn-Tucker duality theory in 1951. Duality theory basically explains that for every LP problem, there is a corresponding dual problem that can give insight into the original one. This was crucial because it made linear programming even more powerful, especially in fields like economics. "So duality helps in better understanding and solving LP problems?" Monica asked, intrigued. "Exactly," Krish said. "It provides a deeper perspective on the structure of the problem. This theoretical expansion made LP much more versatile for practical use." Monica was impressed. "Wow! So, when did industries really start applying LP?" Krish smiled, ready to introduce the next key figures. "That's where Abraham Charnes and William Cooper come in. In the 1950s and 1960s, they showed how linear programming could be applied directly to real-world industrial problems. They worked on transportation, production planning, and finance, proving that LP could optimize supply chains, reduce costs, and maximize profits. Their contributions were vital in taking LP from theory to practice." "That's amazing," Monica said, her eyes widening. "So they made LP practical for industries." Exactly, Krish confirmed. Charnes and Cooper turned it into a tool for businesses and governments to solve real problems. That's when LP really started to flourish in industrial applications. Monica paused for a moment, then said, Okay, so the simplex method was the big breakthrough, but I've heard there was another major development. Something about Karmarkar? Krish's face lit up. Yes, Narendra Karmarkar made a huge leap forward in 1984. The simplex method, while effective, wasn't always the fastest for certain types of problems. Karmarkar introduced what's now called Karmarkar's algorithm, or Karmarkar's method. It's a polynomial time algorithm, which means it can solve large-scale LP problems much faster than the simplex method in many cases. His work opened new possibilities, especially as computing power grew. Monica's jaw dropped slightly. So Karmarkar's method is like the next-generation solution for LP? Exactly, Krish said. It was a breakthrough in terms of speed and efficiency. With Karmarkar's method, industries could tackle even bigger and more complex problems, everything from telecommunications to logistics and manufacturing. It revolutionized how optimization was approached. Monica leaned back in her chair, clearly impressed. I had no idea that linear programming had such a rich history with so many contributors. It's incredible how it evolved from solving wartime resource problems to transforming entire industries. Krish nodded. It's true. Linear programming is one of those mathematical tools that changed how we make decisions in the real world. And it's still evolving, with new techniques and applications being developed all the time. Monica smiled. Thanks, Krish. I feel like I finally understand how LP developed, and I'm even more excited to learn how to use it. Krish laughed. I'm glad. Next time, we'll dive into solving real LP problems and see how it works in practice.